Afternoon. I thought I would just make a quick video on this Squawk problem, this phantom file, rogue file security cycles issue that we've been discussing in Chris's beebjit thread over on the Stardot forums. So what we have here is a beeb setup to catalog what comes in over the cassette interface. And over here we have a recording of the Acorn Electron, side A of the Acorn Electron introductory cassette. And so the first thing we're going to do is just to establish some volume levels. So the volume is currently off. So if we start playing just a normal file on the tape, this is actually the river game file. We'll start off by playing this. And we're going to increase the volume to 1 square. That's as low as it will go, or 1 bar. So now, if you look at the beeb can't recognize anything at that volume level. The bits aren't passing reliably through the serial ULA. So let's increase it 1 more notch. Let's go up to 2 squares there. And we now find that the beeb is able to read files at that volume level. They're passing through the serial ULA, and the ACIA and MOS are interpreting those bytes fine. Now, if we increase the volume, we should find that we can drive this pretty much all the way to maximum, and that this will carry on loading. It's still fine with loading at that high volume level. To the creator's credit, it does seem to be able to tolerate quite a wide range of different amplitude levels on the input there. So let's set the volume to somewhere in the middle. Let's get a sort of Goldilocks level, which perhaps you might have used on a cassette recorder back in the day, somewhere between the two extremes kind of thing. And we'll stop that playing. Okay, what we're going to do now is we're going to run a piece of code that I kind of quickly mocked up, which will print the value of, for every byte that's received on the tape, it will print the value of the ACIA data register, which is the actual byte that's been received, and that will be printed in green. And it will also print the value of the ACIA status register, which appears in red, and that will let us know of any errors any framing errors and so on, which may have occurred during the reception of that byte. So we can start that running. That's been assembled at 4,000 in memory, so that program is running now. So what we're actually interested in here is this so-called squawk, these security cycles, which is like a burst of cycles that appears immediately following this gap on the tape and immediately preceding this section of leader tone here on the tape. So what we're going to do is we're going to go transport looping, set loop to selection, so that we can loop that burst of cycles excuse me, over and over again, and we'll see what the beeb makes of this. So with that kind of middling volume level set, we're going to just start this playing, and we'll see what comes out of the ACIA. Now we're getting, that's possibly the most typical value. That A9D5 is possibly the most common value that comes out when you try this, although there are various values that can occur. You'll notice that if you can see that the status register there is producing hexadecimal 1, 2, and that upper nibble, the 1, is actually, I think it's bits 4, 5, and 6 from the status register, which are those 3 bits encode any errors which might be produced by the ACIA. So that 1, 2 indicates that's the framing error bit, and it indicates a missed framing of that A9 byte, which is what you'd expect if you look at the diagram that I drew in that beebjit thread on Stardot. You'll notice that is what you'd expect. You'd expect that A9 to generate a framing error, which it's doing. So it's quite reliably producing this A9D5 pair of bytes, which is one interpretation of this squawk that occurs on the tape. So now let's try reducing the volume. Let's go down here to a marginal level. Let's say 2, which was the lowest volume, if you recall that 2 squares was the lowest volume at which we got any meaningful output from MOS. It's still doing A9D5, which isn't necessarily what I expected, but this is it's honestly very dependent on, now there we go, there's a 2AF5. That is actually what beebjit does, and that 2A is seen by MOS as the, coincidentally, as the sync byte. There's A9D5 back again. The sync byte, which begins a valid MOS file. So those 2AF5s will be interpreted as by MOS as a valid block, and that's when you get the phantom files showing up. Now we are seeing a few of these 2AF5s, so let's try. Let's just see if we can get those to appear as the phantom files. Now we're at a volume level low enough, and there you go, volume level low enough for that to happen, that 2A to be seen. But it's not as you can see, it's not happening all of the time. It's just occasionally, depending on how the ACIA chooses to frame that bit stream. Let's go back to the ACIA test program. So this is running again now, and we'll start to see stuff coming through from the ACIA. So there's the 2AF5. That's the rogue file, and there's an A9D5 back again. One other thing that I did just want to demonstrate, which is possibly quite interesting, is if we take this section of silence here and we loop this, and then we increase the volume level, we're going to play that, and we're going to start increasing the volume level. Now, this is just silence on the tape. All we're really getting here is tape hiss. But if we start to increase the volume, you will find at a certain volume level that there it is. The serial ULA and the ACIA are now actually seeing silence on the tape as that's now being passed through the serial ULA and is reaching the ACIA. So we're now seeing silence. I'll just turn the volume down a little bit there so it's right on the margin. But silence is now being interpreted as valid bits, which is quite interesting. And of course they've all got that 1-2 framing error again because there's no valid stop bit. The stop bit's supposed to be a 1. So if you're just getting zeros through, then you're never going to have a valid stop bit. So they're all generating framing errors. Yeah, so that's quite interesting. But yeah, there's if we just go back to the Squawk again, there's various different ways that this can come out of the ACIA depending on what day of the week it is, and various volume levels, and it's all fairly inconclusive, unfortunately. There's no see this is at the higher volume level. If we turn it back down, we start to get those A9D5s again. We can increase the volume a little bit, still getting A9D5. Increase it a bit more. There's a 48 A9 or a 48, I don't know, D5 48. Yeah, so you can see that 90 A9, that's a new one. So you can see there are various ways, and there's the 2AF5 back. That's now occurred at a very high volume level. So it's difficult to say what the canonical answer here is. Just trying some more volume levels. It can be interpreted lots of different ways depending on exactly how the ACIA chooses to frame the input. So no conclusive answer really, unfortunately. So there you go.